How's it going, ladies and gentlemen? Mr. Donner here once again with 20.5 spontaneity of reactions, and our objectives are to describe the spontaneity of these cells based upon the electromotive force and calculate the change in free energy. We got a new equation that's going to link the two. Delta G equals negative NFE. So what have we looked at previously? We've looked at delta G of reactions, right? The Gibbs free energy, and if it's a positive value, it's non-spontaneous. If it's negative value, it's spontaneous. And we looked at the cell potentials, where a positive cell potential is spontaneous and a negative one is non-spontaneous. We've looked at free energy and spontaneity. We looked at cell potential and spontaneity. We're finally going to link the two together. So now we're going to relate these two terms, delta G and the E naught. Okay, so delta G equals negative NFE naught. What's all that mean? Well, delta G naught is the change in Gibbs free energy. The N is going to be the number of electrons that are being transferred in our redox reaction. F is that Faraday constant, which is 96,500 joules per volt mole. And E naught is the cell potential. Note that a positive E naught will give a negative delta G because of that negative sign, right? So that's still consistent, right? Positive E is spontaneous, negative delta G is spontaneous. Cool, the math makes sense with what we already know. Yay! All right, so problem. Calculate the change in Gibbs free energy under standard conditions for the following reaction. What you'll need to do for these kind of problems, you get asked that, first thing you got to do is recall delta G naught equals negative NFE naught. Okay? Then you got to determine the balanced redox reactions by doing the half reaction method if they don't give it to you. Okay? Then you also need to, in order to do that, split it up into two half reactions and then look at how many electrons are being transferred. Then you got to determine the E naught by looking at the reduction potentials of the half reactions, because they probably won't give that to you, typically. And then you just plug and chug, paying attention to units. Make sure your units agree with things. So calculate the change in Gibbs free energy for the following reaction, and then they give you this reaction. So first step is, all right, well, let me split it up into two half reactions because I got to figure out how many electrons are being transferred. So I got my silver, I got two silvers gaining 2 electrons, becoming 2 silver 0. I also have 1 calcium becoming calcium plus 2, give me 2 electrons. So basically, how did I figure that out? Well, I took 2 Ag plus and 2 Ag 0, and then I go, how do I balance my charges? Well, there must be 2 electrons on this side so that the charge is 0. I did the same thing for calcium. I started with calcium 0, ended up calcium plus 2, so I wrote those in. And then I said, hey, how do I balance charge? Well, there must be 2 electrons on this side. And then I also looked up the cell potentials, which are given right here. So the reduction potential for calcium was negative 2.87. Remember, if it's being oxidized, you have to change the sign of that, right? Cool. So delta G equals negative NFE. So how many electrons are being transferred? Well, there's 2 and 2, so 2. My N equals 2. But I'm getting ahead of myself. So E naught is going to be that positive 0.799, the reduction potential at the cathode, and minus the reduction potential at the anode. And I get this as my E naught. My N is going to be 2 because there's 2 electrons being transferred. And the F is just a constant. You don't have to worry about remembering that. I'll probably give it to you. So now just plug and chug. Negative 2 equal times 96500 joules per mole volt. Right, and I end up with what cancels out? Volts cancel out, and I'm left with just joules per mole. So I get 708,117 joules per mole, and if I convert that to kilojoules and account for sig figs, I get 708 kilojoules per mole. So yeah, this equation, that's it in a nutshell. Feel free to stop here. I'm going to give you one more bonus problem. All right, bonus example. What's the Gibbs free energy change for the following reaction? They give you this crazy long reaction, and you just, first thing you got to do is split it up. So I go, all right, I see Ni plus 2 is becoming Ni 0, and I look for the half reactions on my reduction potential table. And I see that this is going on, right? I found this reaction and found that potential, and now I'm going to go, hey, okay, I got CrOH3 and I got CrO4 somewhere. Do I see that anywhere? I sure do. Here it is, CrOH3 plus 5OH minus gives me this, right? What I have right there. So now, the question is, well, how do I figure this out? First step, recall the equation. Negative NFE naught. So first you go, all right, I got to figure out N. All right, well, if I got 2 electrons here and 3 electrons there, I know I'm going to have to balance these. So this one, you're going to times the whole thing by 3, right? 3 Ne, 6 electrons, and 3 Ni. Then this one I'm going to have to times by 2, and everything in here is going to get doubled, right? And if you take a look at what happens to the numbers, they start to reflect what's actually in the equation up above, right? Because I have 3 Ni and 3, and that's why there's a 3 in front, because you had to do that to balance electrons. So now my N equals 6. F is at number 96500, and my E naught is going to equal what am I doing? What's happening at the cathode, which is going to be the reduction. Which one's being reduced? We got this one being reduced, negative 2.28, and then minus the reduction potential at the anode, which is 0.13, and I get a negative 0.15 volts, which tells you what? It tells you that this is not going to be a spontaneous reaction. So when I plug it into my Gibbs free energy equation, hopefully I get something that makes sense with that. So I get negative 6 times 96500 joules per mole volt times negative 0.15 volts. And then I plug and chug, and I get an answer of, to 2 sig bigs, 87000 joules per mole. Now notice that this is a positive value for delta G, which tells you that it's non-spontaneous, which is what the voltage also told me. So cool, didn't mess up there. Awesome. That's here, so that hope you found it helpful. See you in class. Okay, bye.